All right, let's go with the last example. Example number 5, 2x squared plus 11x equal positive 6. Now, I have a quadratic equation, but it is not equal to 0. So I have to ask myself, am I going to come up with a quadratic equation that is equal 0 on the left or on the right? Well, to determine whether I should make the left-hand side 0 or the right-hand side 0, it's going to have to come down to the idea of keeping the leading coefficient positive 2 positive all the way through. So to keep my leading coefficient positive, I have to leave the left-hand side alone, and I have to deal with the right-hand side. So I can make the right-hand side equal 0 by simply move the positive 6 to the left by doing the opposite of positive 6, which is minus 6. So on the left-hand side, I have the quadratic equation of 2x squared plus 11x minus 6. Okay, now from here I can try to factor using the x method. So top number is the product of the leading coefficient and the constant. So 2 times negative 6, that's negative 12. Drop the second coefficient down to the bottom. I want to come up with two numbers on the side that multiply together to give me back negative 12 and also add it together to give me back positive 11. Or if I do positive 12 and negative 1, that's going to do the trick, because positive 12 times negative 1 is negative 12. Positive 12 plus negative 1 is positive 11. So that's my two numbers on the side. So I can rewrite the left-hand side into 2x squared plus 12, the one that we come up with on top, multiplying the x, and then plus, in this case I'm going to write plus negative 1 times x like that, okay? Because with the plus side, it's easier to work with. And then I'm going to keep the minus 6 equals 0. So anyway, continue factoring by grouping. Group the first two terms, group the last two terms. Now for the first binomial, since I recognize the fact that the smaller coefficient, positive 2, is a factor of itself and a factor of 12, and also the fact that both of these coefficients have the common variable x. So I get to also factor out the x with the lowest exponential power. So I'm going to factor out 2x in total. Factoring out 2x. In the first term, I'm left with just x. For the second term, the leftover is going to be plus 6. Now what about the next term? Well, for the next term, how am I going to factor out the next binomial? Excuse me. For this one, I have negative x minus 6. Well, I got positive x plus 6. So I have to somehow make this become another one of this. And I can do that by simply factoring out a negative 1. So if I factor out negative 1, I'm left with just the positive x and the positive 6, and that equals 0. Now, for those of you who ask me how I go from minus 6 to positive 6, well, if you just rewrite the minus 6 here into the product of negative 1 times positive 6, well, hey, guess what? After you factor out the negative 1, you're left with just positive x and the plus 6. And the positive 6. Okay. So we got two common terms, factor it out, I get x plus 6, multiply the leftover 2x plus negative 1, so that's 2x minus 1, equals 0. From here, with two binomials multiplying together, use the zero product property and write each of these binomial factor equals 0. So I get x plus 6 equals 0. And I got 2x minus 1 equals 0. Solve for x in each case. The case on the left is going to be x equals to negative 6. The case on the right is going to be equal to 2x equals 1, which is going to give us x equals 1 over 2. X equals 1 over 2. Excuse me. So are these two x values the solution of the original? Is one of them the solution or none of them the solution? We'll just plug each of them in. So if x equal -6, then what? Then x equals -6, and then I'll leave some space over here and I'll fill it out in a bit. Plugging in x equals -6 into the original equation, I want to make sure that the left is going to be the same as the right. So I would have 2 times -6 raised to the second power plus 11 times -6. And is that equals to 6 on the right? Let's do some mental math. -6 squared is 36. 2 times 36 is 72. Positive 11 times -6 is minus 66. But hey, guess what? That's equal to positive 6 on the left, which is the same as on the right. So yes, x equal -6 is a solution, S-O-L. Okay, so SOL is a solution. Now let's do the same thing for x equal positive 1 over 2. So if x equal positive 1/2, then x equal positive 1/2, whatever after, we plug it in. Plug it into the equation of 2 times 1 over 2 square plus 11 times 1 over 2. Well, let's see. I'm going to simplify the left. With number 2 by itself, because I'm working with fraction, I'm going to rewrite 2 into 2 divided by 1. So with 2 over 1 times 1 over 2 squared, that is the same as 2 over 1 times 1 over 2 times 1 over 2. And then for this one, this is going to be 11 over 2. And then keep the equals 6. Well, for the whole chunk on the left, I have 2 over 1 times 1 over 2 times 1 over 2. Well, I can cancel out the common terms too. 1 is just there, you know, anything multiplied by 1 or divided by 1 is just itself. So I got 1 times 1, which is 1, divided by 1. Divided by 1 times 2, which is 1 over 2. So this is 1 over 2 plus 11 over 2. Is that equal to 6? Well, hey, guess what? We got two fractions adding together that have a common denominator. So keep the common denominator and add the numerator. So I got 12 over 2. Is that equal to 6? And yes, it is. So the left-hand side 6 is the same as the right-hand side 6. So that means x equal 1 over 2 is also a solution. Because all of these x values are the solution of this equation when we plug each of them in to confirm that the left-hand side is the same as the right-hand side. That means we have all the solutions and we don't have any extraneous solution. So that means we write no extraneous solution. And of course, I recommend you to always write no extraneous solution as an extra step, just to be careful on the test or quiz.